Hello everyone. This video I'm going to demonstrate an example from textbook. Okay, it's calculating the work done by the bearing force. And the problem is in this example 6.5 it says if okay it says there's a work there's a bunch of workers. They want to push the car, push your trunk. Okay, trunk or car trunk. Okay, let's say a trunk, TRU, the trunk, and push the trunk for over 10 trunk over 10 meters at the rough surface, and they want to move the trunk with a constant velocity. Okay, constant velocity. I think it's constant velocity. And let me check. Is it trunk or truck? Example 6.5. Trunk or truck? Okay, trunk. Okay. So, and the mass of a trunk is 180 kilogram. They want to move this trunk over a rougher surface of 10 meters and at the constant velocity. So and they want to calculate the problem as to calculate the work. Okay, and the work. And it also states that the surface, the rough surface, its kinetic coefficient is a function of x. Okay, yeah, it's possible. It's possible because we cannot it's impossible for the surface has a uniform kinetic coefficient. Sometimes it could be very as very is a function of space. Okay, it's very possible. Okay, there won't be a uniform kinetic coefficient of surface. Okay, so it says the kinetic friction coefficient is as a function of x, and what's the value? Let's say it's 0.17 plus 0.00 or 0.00062 x squared. Okay, so let's analyze this problem. So they want to move the trunk with a constant velocity. Yeah, this is also a key point. If they want to do the constant velocity, push the trunk in with constant velocity. That means your push force. Let's say your push force. Okay, is equal to is the minus the equal to the reverse direction of the friction. Okay, I should say friction. Okay, friction. Okay, kinetic friction. Okay, yeah, because you apply force or push force must be equal to the reverse direction. It must be up just right opposite to the friction force, and then you will have constant velocity. If your push force and reaction and the friction force is not equal, then the force is not equal, you will, based on the Newton's second law, the force will cause the acceleration, right? If you have acceleration, that means you won't have a constant velocity motion. So if you want a constant velocity motion, your force must be equal to your push force. In this problem, your push force must be equal to right opposite to the friction force. Okay, that's a very important key here. Okay, so what's the work? Okay, so and we see this problem say that the friction coefficient, kinetic friction coefficient, is a function of x. So that also mean that this can imply that your friction your friction is also function of x. Yeah, it's very simple. The derivation, right? Your kinetic friction coefficient is function of x, so your friction force must also be function of x. Okay, so let's for this problem, that we assume is 1D motion, and there is no acceleration in y direction. Okay, yeah, it's a 1D motion along the x and there's no acceleration in y direction. Okay, the force, well, so let's calculate the force because the force is varying. Okay, because the push force is the right opposite of friction force, and friction force is a function of x. That means your pushing force must be also the function of x to make the constant velocity motion. So let's say, okay, because one dimension, let's get rid of this vector. So we all assume it's one dimension. Okay, so we don't need to use a net vector notation. Okay, f of x and function of x is it's push. Okay, push. Okay, function x and dx to the integration. And when we do integration, we have a range. So let's assume the starting point is 0 and final position is 10. Okay, so your force is the negative of is a reverse of friction force. So it would be so minus so your friction force, let's say, okay, let me see. Okay, so your friction force is to turn the direction of friction force is to the left, so it's negative, but we have the negative sign in front of the friction force, so it will eventually become the positive. So it's equal to mu k in the normal force and dx. And and also we assume no acceleration in y direction. That means your normal force is equal to the weight of the trunk. Okay, don't forget about this. There's no acceleration in y direction, and use the Newton's second law, you'll get your normal force just right equal to the weight of the trunk. So let's say, okay, nu k mg, and m is 100 kilogram. Should we have write this down here? Okay, so let's write this down: 180 and 9.8 and dx. Okay, so and we already know the expression of kinetic friction coefficient, so just write it down. So 0.17 plus 0.0062 and x squared. So what's the value of the 180 times 9.8? Okay, let's do the calculation again. Times 9.8. So its value is 1764 and dx. Okay, and then we just do some algebra work. And so what's the value of times so 299.88. Let's make calculation easier. Let's just take it as 300. Okay, so plus 1.64 times 0.0062. So it's 10.94 and x squared dx. Okay, so we'll finally have to do the integration of this, and we will find how the work you need to push, how the work you have to done on this object to maintain a constant velocity motion. So the integration also value the distribution law. So there's two terms in there. So we just do it slowly. Okay, so we can factor this out. So the first term is this one, 0.10 300 dx plus 0.10 10.94 x squared dx. Okay, so this is a power function integration, and it's very easy. So I'm not going to show the detail here. So I just write down the formula here. The power function x1, x2, x dx, x and dx is equal to 1 over n plus 1, x2 n plus 1 minus x1 n plus 1. Okay, that's the integration. The integration law for power function. So we apply the power function here. So this is a constant. Constant means x to the power 0. Okay, that means n equal to 0. So it will become just the constant dual integration just equal to 10 minus 0. Okay, constant 300 can factor it out. So we have the 1 doing the integration of 1 dx and from 0 to 10. and 1 is x to the power 0, so n equal to 0. So that's practice by yourself. And the other one is the minus, I'm sorry, it's plus, is 10.914 and x to the power 2, so it will become 1 over 3, 10, 3 minus 0 power 3. So let's calculate what's the total work. Okay, it's 300, so 3,000 plus, and it's 10 power 3. Okay, let's do a calculator. 10 power 3, 10 power 3 minus 0 divided by 3 times 0.94. So it's 3646.67. Okay, so add it together, that just round this thing off. Okay, round this thing off and make it 7. Okay, so it will 6647. 6647. And if we want to do the prefix, it's about 6.6 kilojoule. Okay, yeah, I think the answer is in textbook. The answer also 6.6 kilojoule. Okay, so that's the example from the exam. That's the example 6.5. Yeah, the integration is a little more difficult, but believe me, the power function integration is already is the simplest integration. Okay, like I said before, there are lots of weird integration in calculus. Okay, the power function integration is the easiest one, so it's not that difficult. So try to practice it. It's really not that difficult. So I just stopped the video here. In the next video, we will introduce another kind of energy, so-called kinetic energy. Okay, let's stop the video here. See you in the next video. Bye bye.